All right. So one thing I want to emphasize before we move forward is this, because I was talking about this with Drake, right? The idea of I'm not sure when to take things away, right? We take away when we don't have something that would work. And so I will say this, some of us are remembering some details, like here, some people have found out and just remembered that between 1 standard deviation above and 2 standard deviations above is 13.5% of the data. And I can show you where that comes from. Or you can just memorize it. But, and so notice, like if I want 2 below to 2 above, how much data do I have? 95%. And then I don't want this, so I take it away. However, and this is something I'm realizing I can be more clear about in the future, when we talk about that 68, that 95, that 99.7, that's always referring to the area in between, right? The area in the middle of the curve. This is the area in the middle of the curve, isn't it? This is area in the middle of the curve, isn't it? So instead of trying to take something away, I can just not take away, but add them, put them together, right? Because there's what key idea around this blue line that goes through the mean?
Symmetrical.
It's symmetrical. And so if there is symmetry and everything from 1 below to 1 above is 68%, what's just this little piece here? Well, it is half of 68, which is 34%. Okay? And then, so that gives me this piece. But then what's from 2 below to 2 above?
95.
But how much of that 95 do I have? I only have half of. By the way, have you ever noticed that whenever it's a fraction of, that literally means to multiply? Whenever you have a percent of or a fraction of, you just multiply. Like that's literally the mathematics behind it. So half of 95% though is 47.5%. And then just add them. Now remember, on assessments, you're going to have to what with your answers? Justify them. Not necessarily they have to use words, that could be even extra information, but is this clear evidence of how I got that 81.5%? 100%. Could I have just labeled it as, hey, this is 47.5% and this is 34%? 100%. Would that be evidence? Yes. This would be a little bit stronger evidence of understanding, maybe a CCC or even a CCC+, but this is also clear evidence that you understand what's happening. So keep in mind, like, you need to show me where you're getting your answers, not just getting an answer. We good with that? Now, in contrast with that, I want to point this out. Notice, do I want area in the middle here? No, I want a tail. And so when I have a tail like this, I don't have the middle. And so if I don't have, well, I'm not going to add, I'm going to subtract, right? And so still using symmetry, right? What's everything to the right of the mean? 50%. 50%. But I don't want this section. How am I going to find this section? Well, this section I don't want.
1 to 1 and then divide by 2.
Right, 1 below to 1 above is what percent of my data?
68.
And I only have half of it, and I don't even want that half, but what's half of that 68? 34. And so if I take 50 and I subtract my 34, what am I left with? 16%. So think about, am I adding the centers together or am I trying to take away? Because if I'm putting stuff together, I'm just going to use what operation? Addition. If I'm trying to take away, then I'm going to use subtraction. What are your questions about this process? Does that hopefully answer some of the struggles that we had? Drake says yes. Crystalline says yes. Okay. And so again, I want you to remember, like, I just need you to engage in these conversations because it's based on your conversations that I knew how to talk about some of these things and how to teach it a little bit better. So engage, struggle, learn, and I'll support you afterwards. Now what I do want you to do is, I gave you a check your understanding yesterday for empirical rule. I would love for you to take some notes. I'm going to give us a total of 8 minutes. So if you finish taking notes, then go ahead and start on check your understanding before we get started with the next part of our lesson. Does that answer your question about the context? Does that make sense now? It's just, what does that mean in context? Well, 13.5% of the time sheets between those. Please note, it was not asked, but you see how I interpreted the mean and standard deviation? That is something I'm going to expect on assessments, so that's why I included it here. Remember, a mean is just a typical value, or on average. So that 6 p.m., she typically, or on average, eats at 6 p.m. At the core, a standard deviation is a typical amount the data deviates or differs from the mean. And so a typical amount Yesenia's eating time differs from the mean is 15 minutes. That's what we mean by standard deviation. That's how you will interpret it in the context every time. This one you can assign it. That's a great notice for this one. That was what you were kind of asking about earlier with the taking away. So if I want just this piece, right? Well, I'm still looking at the center, but I took away this center piece that I don't want. Yeah. What questions do you have about these problems before we continue? These questions. Do you notice I justified answers? I didn't just put answers down. That is, one, hopefully helping you understand it a little bit better, but two, greater evidence of understanding. Okay, in about 60 seconds, I'm going to continue on to the next lesson. Make sure you have these answers down. And we will continue after that. You good with this? I know you're not having fun with some of this yesterday. Bullet point number 4. So notice what I did with this one is, I know what I'm missing. And remember, 0, 1 above, 2 above. The fact that I'm trying to go to 2 above tells me that we'll get 95%, 68, 95, 99.7. But I don't want up to the 1. Okay, and I only have half of each of them, so half of that 95% is 47.5%. This that I don't want is half of 34%. And notice again, for half of 68, which is 34%. And remember, what we just said is we don't want it. What do we do? When you don't want something, we subtract. Right? We already halved it because we're only looking at like half. So I did half of 95% to get up to. But then I had to do half of the 68% because I don't want this section. And that's what percent deviation. And what I don't want, I subtract that. Does that make sense? Yes, ma'am. I'm gonna collect it tomorrow before class. So I'll give you a chance to ask those questions then. Okay? Or at the beginning of class tomorrow. Or right after class, but we gotta move to what's called z-scores. I didn't give you all to check your understanding on z-scores yet, have I?
No.
Are you sure I didn't pass them out at the same time as the empirical rule stuff? Oh, I did pass that. I didn't give you 2 check your understandings when I gave you. That's more about the study. Well, as we start the next activity, I guess I'm going to be printing this and wasting more paper. I'm not upset about it. It's okay. That's my fault.
Play dumb games and win dumb prizes, right?
Alright. Z-score is what we're about to talk about. It's not something we've studied yet. Don't sweat that. Alright. So let's pick up here. We are moving on to lesson 3, which is the last part of lessons 3 and 4, but lesson 3 really is the last part that will be assessed on the test. Notice right here we are moving into this part about percentiles. We're going to do a little bit more of finding the percent of data between 2 values on a normal curve, but then we're going to use z-scores down here, which will tackle z-scores and percentile. That is the last little bit of this proficiency scale, the last little bit of content that we're going to cover. Okay? I'm not going to ask questions or ask if you have questions about it because we haven't studied it, and I assume you've never heard of z-scores before. Is that fair? Yes, Mr. King. Thanks, guys. I appreciate the engagement. All right. We've just been doing a ton of this, so I'm going to skip the getting started, and we're going to move to 3.1. All right. So we should be at 3.1 from the book. I'm assuming it's like page 34 or so, maybe 35. 35. Thank you, Jaden. Now we're getting there. All right. So I need us to pay attention to this because the empirical rule is great, but it has a major flaw. Not a flaw. Let me correct that. It has a problem at times. Okay? So, number 1, let's consider the fuel efficiency of hybrid cars again. By the way, that is based on the getting started. What they talk about in the getting started is that hybrid cars have an average fuel efficiency of 54 miles per gallon and a standard deviation of 6 miles per gallon, which I'll say this. I wish my car got 36 at the minimum, but whatever. All right, so hybrid cars have an average of 54 miles per gallon with a standard deviation of 6 miles per gallon. From there, we are asking what percent of cars get less than 57 miles per gallon. Okay? And so a question that I have for you, or the question that we start with is, how many standard deviations from the mean is 57 miles per gallon? Half a standard deviation? Why is it half? Sorry, that printer's printing. You're going to have to say a little bit louder.
Because it's in between the mean.
So if it's in between, it's just always half? So why is this one half? I need some more clarification. Why is 57 half a standard deviation above the mean?
Because it's an equal distance between the mean and...
Okay, so one way to say it is it's an equal distance between the mean and one standard deviation above, right? So halfway. But I will point this out. Do you think it's always, we're always going to deal with things that are halfway in between? So let's look at another way to find that. Let me point this out. How far away is 57 from the mean? 3. How did you get that though? So you took 57 and you subtracted 54, which is the mean. And notice the standard deviation was how much again? 6. So what could I do to this 3 to get 1/2? Using that 6, what could I do to that 3 to get 1/2? Not divide it by 2. What could I do to 3 with the 6 to get that 1/2? I would say 3 divided by 6, right? So what I want to point out here is this. If I want to find out how many standard deviations a value is from the mean, okay? So how many standard deviations a value is from the mean, what we do is we take the value. What do we do to that value? Minus the mean. That tells me just how far away it is, right? If I take a value and I subtract the mean, that's how far it is. And then what do I do to that value minus the mean? Divided by, okay. That's how many standard deviations a value is from the mean. And so that's why it's half the standard deviation. And so noticing it's halfway in between is great for this problem, but if I deal with something else, I need to know how to do this, right? So if the fuel efficiency had been 55, then it would be 1/6 of a standard deviation above the mean, right? That's not a part of this problem, but I just wanted to point out if I was looking at a value of 55 miles per gallon, it would be 1/6 of a standard deviation above the mean. You can convert that to a decimal, but you don't have to. Yeah, sorry. Okay. Now there's one more thing I want to point out about this before we move to B. Let's say I have a value of 46 miles per gallon. And I want to find out how many standard deviations that 46 is from the mean. What am I going to do to that 46? Subtract 54 the mean, and divide that by 6, the standard deviation, which now gives me, why did that become negative? It's a negative. Why is that a negative value? You're telling me numerically why it's negative, but like in the context of the normal distribution, why is it negative? Say it again. We want to notice and remember, right, with that standard normal curve, remember how it was 0, 1, 2, 3, and -1, -2, -3? The negative indicates that it's what? Below the mean. Does that make sense? So, great note on that to me, right? We want to notice if it's a positive value, it's above the mean. If it's a negative value, it is below the mean. Does that make sense? So hold on to that note. It will matter later within this lesson. So I'm going to let you write notes about that while I set up B. And so in B, again, we're looking at the situation of, was it 56 miles per gallon? Or 57, sorry, for lying to you. So we're looking at 57. And so Demetrius incorrectly estimated the percent of hybrid cars that get less than 57 miles per gallon. Actually, I don't want any of this. Okay? He incorrectly estimated that the percent of hybrid cars that get less than 57 miles per gallon, and so Dimitri said it's approximately 67 that get less than 57 miles per gallon. And he said 50%. Where's that 50% coming from? So everything from 54 over, right? That's half the distribution. Then he added to it half of 34. Where's half of 34 coming from? Right, so from 0 to 1 is 34%, correct? But they're telling us that's wrong. I want you to take 60 seconds to talk about that with your group, and we'll bring it back together to see if you have an idea of why that is wrong. And I can confirm that is not correct. So talk with your groups for about 60 seconds, and we'll bring it back together. Ooh, that was a good conversation, very quick. You agree with that statement, Davis? So the whole reason we're able to do halves earlier is because to the left and to the right of the mean is what? But now, is it?
It's wrong.
I got a couple of groups that have conversation. Jump on with me again. Still thinking. No ideas? Landon? Jump on with this? Nothing? You don't see anything that's wrong with it? Alright. Let's bring it back together. Davis, what did y'all talk about? What's the issue? It's not what? Why were we able to do half of 68, half of 95? Because there was what around the mean? Symmetry. But when I look right here, is it symmetrical here and here? Oh, no. Notice this part's shorter. So is this 17% and this is 17%? No, there is more area right here. Okay? So, note this, empirical rule only works for integer numbers of standard deviation above and below the mean. And again, why was that? Why did the empirical rule work for all the integer values of standard deviations? Because of what key concept? Because of symmetry. As soon as you get half of a standard deviation, a sixth of a standard deviation, a 20th of a standard deviation, the empirical rule goes out the window. It is not possible to use. As soon as you get a fraction of a standard deviation, that empirical rule goes out the window. So we need something new. Any guesses what that new thing ties into? Say again. I heard someone say it.
Z-scores.
Z-scores, right? What was this whole lesson about? Oh, Z-scores. There we go. I wasn't trying to hide it from you. Told you it's Z-scores, okay? So we need a Z-score. You know what a Z-score is? Yeah, no, right? No idea? Nah. What if I were to tell you that that 1/2 we calculated earlier is a Z-score? What if I were to tell you this 1/6 that we calculated earlier was a Z-score? What if I were to tell you the -4/3 we calculated earlier is a Z-score? What do you think a Z-score might be then? Doesn't have to be a fraction.
Well,
I wrote something on the board that tells you exactly what a Z-score is.
How many standard deviations value?
How many standard deviations a value is from the mean, that is a Z-score. This is what a Z-score is. And you know how we calculate a Z-score? That's how we calculate a Z-score, so I'll rewrite that up here. Now, please hear me very clearly. This is how we calculate it. This is how we calculate it. This is what it is. There's a difference between how to calculate it and what it is. Are they related? Heck yeah. Are they the same? Heck no. Good job. They are very much related to each other, but they are not the same thing. Okay. Now, you can write these notes in your book, or you could put these on the prayer model that you don't have. But I'm passing out right now. You can always transfer it over later if you want. By the way, I have a hole puncher at the front of the room on the Student Work Center if you want to hole punch it later.
My charger broke.
I returned those earlier. By the way, once you're done taking those notes, everybody needs a calculator for the next piece. Once you're done taking those notes, everybody needs a calculator for this next piece. All right. Show me how many more minutes you need on your hands to take notes. 1, 2, or 3. 1 minute, 1 minute. Okay. While a handful of us are still taking notes, I will point this out. If you go to the very next page in the book, I believe, it gives you a definition of what a z-score is. I like my definition a little bit better. I think it's easier to understand. But if you like that definition, go with it. Notice in the bottom of that page, it talks about what would a negative z-score indicate. We already talked about that. A negative z-score indicates the value is below the mean, okay? So, you'll notice also right here, there's a table. This table allows us to take a z-score and find the area under the standard normal curve. So the z-score, by the way, perfectly lines up with the standard normal curve, right? Mean of 0 in the middle, 1, 2, 3 above, 1, 2, 3 and below. And so you can use a table, but you know what? I live in the 21st century, so instead of using a lame table, you know what I'm going to use? I'm going to use that calculator, okay? So you can learn how to use the table, but it is actually a bigger pain in the butt because you have to account for taking areas away and all this stuff. And so what I'm about to show you is how to use the calculator with that z-score that we just computed. Okay? So, we're going to the next page 37 where we use a calculator. So, I need everybody to create a calculator page if you do not already have one. Can I erase all this on the board? We got what we need? Okay, so create a calculator page for me. Now, let's see. Sarah, remind me, what do I press if I'm going to do cool crap on this calculator? Menu. So once you have a calculator page, let's hit menu. All right, from there, Malia, any guesses based on these options where I might go if I want to do something with these z-scores? Hey, Davian, set that to the side so that I can look at it later and make sure to figure out how to make it work, if it's not right now. So you already hit, no, you have to create a calculator page first, so hit 1 for new documents. Guys, you need to be on a calculator page like this to be able to hit menu. So calculator, so Malia, do you see any options that might let me do stuff based on what I'm trying to work with? There's 2 options. Think about what we're studying right now. Always, it's algebra 2 with statistics. So Malia, any guesses where we could go? Statistics. You can, in this rare instance, also go to probability that we use for random stuff. I'm going to go to statistics, though. I want you to look now at this list, because I want us thinking about these lists. What did I call these curves earlier? Because there's an option that ties into that. It's a distribution, right? So we go to statistics, we go to number 5, distributions, and oh my goodness, what type of distribution is it? It's a normal distribution. Okay, now pause for a second once you hit normal, because there's a couple of options, or don't hit normal yet. I'll go ahead and tell you this. If you ever take AP Stats with me, I'll explain why, but normal CDF is the only one we're going to use right now. Normal PDF has a use, not really that we'll ever care about. Inverse normal we might get to, I can't remember, but definitely normal CDF. Now, this is the detail that students struggle with regularly, is lower bound versus upper bound, okay? So, I want us to look at this curve. The bounds are referring to what we are shading, okay? And so, that's a little off, but it's fine. Now, remember how we converted to our z-score, right? It was 57 miles per gallon, but we converted that to a z-score. What was that z-score again? Thought it was 1/2, 0.5, something like that, 0.5 for 57. Because remember, it was 54, then 60, and so the value minus the mean divided by my standard deviation. So 6 is my standard deviation. Is 3 divided by 6, or 1/2. Okay. So remember, this is one standard deviation, or a z-score of 1, a z-score of 2, a z-score of 3. So I went right here. And then which direction did I shade? To the left, right? We wanted everything below that 0.5. Okay? So what is the lower bound of that shading? What do you think I mean by lower bound? Over here or over here? Left. When we say lower bound, we just mean the leftmost value. Notice how it goes beyond -3. So you could probably do -5, that'd be more than enough, -10, -100, but it needs to be something beyond -3. I'll do -10. And then what's my upper bound? What was my upper bound? Remember how I stopped shading at that z-score of 0.5? Okay, so I do an upper bound of 0.5. And remember our original curve had a mean of 54 and a standard deviation of 6, but we converted it to the standard normal curve. Whenever I use a z-score, that's a standard normal curve, so what's my mean and standard deviation? So we can leave that there. Once you have this filled in, you hit enter. So you need your lower bound and your upper bound. We should all have 0.69 or so. 0.691. Okay? So, this area, so the area is 0.6914. So what percent of cars get less than 57 miles per gallon? 69% of cars get less than 57 miles per gallon. A note that I'm going to add on to this before you finish writing your notes for this is that also means there is a probability of 0.6914 that a car gets less than 57 miles per gallon. So notice the probability and the percent are same, or very similar, but it's the idea that 69% of all cars get less than 57 miles per gallon. So the probability that one car gets less than 57 miles per gallon is 0.6914. So we see how that probability and that percent of data is very heavily correlated, right? So the probability is just a decimal percent, and it's also for a single thing to happen, whereas a percent is for all the cars. So update your notes either in the book or on the Frere model. Yes, ma'am. No. So the probability is just the area under the curve, the decimal. Notice that's another thing to note. The probability is the area under the curve. The percent is the percent of all the data of all the cars. Okay? So probability is the decimal value. Thank you for that question, Colin. Sorry, I'll get out of the way. All right, what are your questions before you get some practice with this? What do I have on the documents? Oh, really quick note. If you go back and you look here, If you look at what it said in the table, 0.6915, 0.6914. So does it matter if we do table or technology? No, but I can tell you this, technology is way easier. Okay, so we're going to use calculators for this instead of the table. If you're just like have a real hankering to learn how to use that table, let me know and I can teach you outside of class time. All right, so 3 and 4, we're done. There we go. So I want you to tackle, let's say 5, 6, and 7. One thing I will note is a lot of students ignore me on this. However, it's going to make your life way easier if you take the time to shade it, because or to draw the normal distribution even when you're using technology. Because if you draw it out and you shade it, you can clearly see what over here. This is going to be the think about from the calculator. Remember, upper means it's on the upper side. Lower bound is on the left-hand side. Upper bound's on the right-hand side. Okay? So let's try 5, 6, and 7 there. And we just won't get to percentiles today. We'll tackle percentiles tomorrow. And DYU after that. Really quickly, because you will need a calculator at home to do this normal distribution stuff, I just found one online that will work pretty well for these purposes. Like if you use strength and understanding, things like that. Typically we do go for the area to 4 decimals, percents, 1 decimal. So those are the answers. So you can check yourself, but again, that's the website that I would use. I think it's laid out pretty well. Because you put in your mean, you put in your median, put in your z-scores, much like you do on a civic calculator. There's 5, 6, and 7. So be aware tomorrow, we're going to have a demonstrate your understanding. And then after that, we'll do percentiles. That's the only thing we haven't covered. So you should be able to do everything on check your understandings except anything with percentiles. And we'll do that first and then do a demonstrate your understanding and review for the rest of the day. Review half of Monday, test on Tuesday.